Hello, everyone, and welcome back to another Math 170 concept session. My name is Nick, and I work at the ASU Tutoring Centers. Today, we're going to be talking about the function e to the x, how to graph it, also how to find the domain, range, and asymptotes of e to the x. So first things first, let's go ahead and just graph e to the x. Now, even though there's no, so normally, right, whenever we have a regular slope intercept line, right, like y equals 4x plus 5, we know that it breaks down into the general equation of y equals mx plus b, right? And we know that b is our y-intercept, correct? That's where it crosses the y-axis. With e to the x, there is no b, right? But whenever we plug in e to the, basically whenever x equals 0, so we have e to the 0, that actually equals 1, right? Because anytime you have an exponent to a power of 0, that actually equals 1. So we know that it's going to cross the y-intercept, or the y-axis at 1 here, okay? Now, the way the graph kind of works, and we'll kind of talk about it a little bit more in a little bit, but this is going to be the general form of the graph. Something kind of like that. So it doesn't ever cross the x-axis. It gets extremely close to the x-axis, but then it almost kind of goes up in a similar shape to like a parabola, almost, right? It starts to concave up, as you would say. So that's going to be the general graph of e to the x. Now, when talking about its domain, right, we're going to be talking about all of the different values that x could equal, where we would get an actual output, right? So, and kind of like when we first started thinking about this, we need to think about, okay, so x can go to positive infinity and x can go to negative infinity. So we need to think about, are there any values in between negative infinity and positive infinity where the values would not work? We would not get an actual answer, right? So first off, thinking of all of the possible, let's start on just like positive values, right? So would e to the 1 million, right? Would that produce a solution? It would, right? Just like how e to the 2 would, right? It produces a output of y, right? So now let's think about, so we know that all positive values are good, right? So we know that from 0, because we know that 0 is a value, right? That equals 1. So we know from 0 to positive infinity that there are no values in between there that wouldn't work for this equation. Now let's think about the negative numbers. So would e to the negative 2 work? Well, e to the negative 2, since we have a negative exponent, what that would actually equal is 1 over e squared, which does give us an output, right? Because we know that e to the second, right, is an actual output, right? So we know that that denominator is going to be a number, and then we just do 1 over that, which equals an actual number, right? So we know that all negative numbers based off this also work. Therefore, making the domain of e to the x equal to negative infinity to positive infinity, okay? Now, for the range, it's a little tricky, right? So we know that as we increased positive numbers, right, we know that e gets increasingly large, right? That's why we have an upwards facing slope here on our graph, right? That as x continues to get larger and larger and larger, our y value continues to get larger and larger and larger as well. So we know that it goes to positive infinity, right? But if we look at the negative numbers here, and it kind of goes back to what we were talking about with domain, but does the y values ever become negative, right? So we know that our positive y values, or as x gets larger, we know that y gets larger, right? But over here on the left side, as x becomes negative and goes to negative infinity, it actually doesn't really go below 0, right? And that's because of what we talked about up here, right? So as e becomes more and more negative, so like let's try negative 2000, what that just becomes is a fraction, right? We have e to the 2000 here on the bottom, which is a increasingly larger number, right? So negative 2000, or e to the negative 2000, or let's just say e to the positive 2000 is going to be larger than e to the 200. And e to the 3000 is going to be larger than e to the 2000. So this number in the denominator is getting increasingly larger, which as we increase the denominator in fractions, we get closer and closer to 0, right? That's why 1/4 is greater than 1/6, which is greater than 1/8, but it's all still greater than 0, right? So what this tells us is that no matter how large in the negative direction our x value is, we will never cross 0, which means then that our range would encompass, not including, so this is a parenthesis, not a bracket, 0 to positive infinity. And then, as we said, there is an asymptote, a horizontal one, at x equal, or y equals 0, right? Because our y values will never cross 0. It will get as close as humanly possible to 0, but it will never actually become 0. Okay, so hopefully that was a good overview for you of e to the x. If you have any other questions on this topic, go ahead and check out tutoring.asu.edu. On there, we have a list of all of our tutoring center locations, as well as all the additional free resources at your disposal from being an ASU student. We have tutoring centers located on all 4 major ASU campuses, as well as an online tutoring center. So definitely check us out. If you enjoyed this video, go ahead and click on that other link on your screen. That'll direct you to a different document that lists out all of the various concept session videos that we have made for this class, Math 170. So go ahead and check that out at your earliest convenience. But other than that, that's all I have for you today. So I hope you have a great rest of your day and good luck in your course.